registration form in the group chat. If you could just please sign in with your name, company, title, email address, and phone, lets us know that you were here and attended. The chat is over on the right-hand side of your video conference screen. Thank you, Richard. I want everyone to click the link that's located in the chat and not put your registration information in the chat. I'm going to post that link again here. We need to leave the chat open for any of our links and stuff like that. So there's a link in there with, it starts with docs.google.com. That'll take you to the registration form. Thank you. As everyone's coming in, I just want to let you know that this is being recorded. And if you are unmuted, I'm going ahead and muting you. In the chat, I'm going to place a link. And for those of you who have come late or later, not late, you're not late, go ahead and register at that link. And I'll be posting that here shortly. Thank you. Thanks for joining so far, everyone. We're just giving it a minute so we can get folks joined in here. Hi, folks. I think we're going to get started here shortly. Thanks for bearing with us. Wish I had some music or something to entertain you this morning. I'm going to post a link in the chat. For those who come in after I've posted it, I do need to repost it. So that's why the announcement again. But if you could please use that form in the chat in the right-hand side to register yourself so that we have you on our attendance sheet, I'd greatly appreciate that. And I'm going to go ahead and post that now.
Good morning, everyone, and welcome to the NWSC Virtual Site Tour. I hope during these unprecedented times, you, your family, and friends are all healthy, and I hope you guys are taking care of yourself and staying safe. My name is Irfan Elahi, and I'm the project director leading the NWSC-3 project and procurement. I also head the high-end services, and my team manages all of the supercomputers, the high-performance storage file system, as well as the tape archive system for NCAR. Now, ideally, I would have liked to host you guys at the NWSC in Cheyenne itself, but unfortunately, here we are. So just to remind you once again that this session is being recorded. And if you have any questions after you have filled out the registration form, you can post your questions using the chat function, and Summer will give you more details later on how to ask questions. I also wanted to remind you that the NWSC-3 RFP proposals are due by May 15th, but we are looking at some extension, and Allison Probst, who is our contract manager, will be providing communications later on. And also, for the most recent RFP documents, please visit our website. We provide weekly updates to question answers, as well as if there's any news item on it. So before we begin with the introduction of the NCAR staff, I just wanted to tell you I really admire all of the work that you guys are doing in the field of high-performance computing, which really helps us push the envelope in science, especially the Earth system science. And I also wanted to take this opportunity to let you know that our current supercomputer, Cheyenne, is part of the White House's COVID-19 High-Performance Computing Consortium, which provides COVID-19 researchers worldwide with access to high-performance computing resources. And we are very proud of that. Summer, do you want to move to next slide, please? So before we start with the tour, I just wanted to give a shout out to all the team members who are involved with the NWSC project, as well as have contributed to this virtual site tour. Allison Probst, she's our subcontract and procurement manager. She's also on the call. Michael Kircher, he's the plant manager, and he will be giving you the site tour. Tracy Baldwin is the project manager. Gary New is the operation manager at NWSC. James Van Dyke is the group lead for our operations there. They manage a lot of the first level support for Cheyenne as well as other resources. And Summer Wasson is the education and multimedia specialist. Next slide, please. Mick Cody, he is the head of user support. So whenever our users have problem, especially with the deployment of NWSC-3, his team will be involved in a lot of the acceptance testing. Pamela Hill oversees all the storage group in our section. Jared Baker is the system lead. Carla Lefevre is the technical writer. Ben is a subject matter expert on HPC, and Mark Genty is the technical lead for storage, as well as he manages the tape library. Next slide, please. Allison, do you want to say a few words about contracts guidance?
Yes, thank you. Good morning, everybody. Thank you so much for participating. It's just great to see the number of people on this call, so thank you so much. Just some basic things I wanted to cover very briefly, and then we'll get right into the guts of everything today. So basic rules about communication during this RFP process. All communication needs to come through me. So although you may, you just heard a list of names of individuals with UCAR and NCAR, you need to make sure that if you have any communication regarding this RFP, it goes through me, because if you do reach out to one of them, they're just going to end up forwarding your communication basically to me. So please just communicate with me directly. Even if it's something I just need to pass on, please do that now that we're in the RFP process. We always strive for the communications to be directed through one point of contact. So I appreciate that consideration. And then we have extended the due date. I'm sure everyone's going to be excited to hear this, for questions. Instead of today, it was previously today at 5 p.m. Mountain Time. It's going to be next Friday, so Friday, May 1st. And those questions, I've already been getting quite a lot of them. Those questions just need to get emailed to me in writing. And so again, you have another week to send further questions in. And we are responding to those questions as quickly as we can. Every Monday, we're updating the question and answer document on the procurement website. So look for on Monday the updated document again next Monday. And then just a reminder, please thoroughly review the RFP instructions before it comes time to submit the proposals. We ask that you separate out the technical, price, and business volumes, because we review the technical separately from the price and business. Different individuals are reviewing those sections. So it's important that we have those separated. So please do that when you submit your proposals. And please make sure that pricing is not contained within the technical volume. All right, thank you very much.
Summer,
Yes, thank you. So my name is Summer Wasson, and I'm the multimedia specialist. I'm normally the tour guide at the facility, so here I am taking part in the virtual tour today. This meeting is being recorded. I just need to let everybody know that. Please remain muted when not speaking. So just some of the general housekeeping rules for this video call today. There is a video chat window on the right-hand side of your screen, and to kind of give you the lay of the land of your video conferencing screen, if you haven't used Google Meet before, at the bottom in the lower left-hand side is the title of this meeting, as well as a link to the agenda. You can reference that if you need to. That window pops up from the caret. There's also a mute button, and then you can turn your camera off. If you do need closed captionings turned on, that is a feature on that toolbar at the bottom as well. And then the chat window is in the upper right with a small chat icon. Please reserve the chat window for questions or moderator assistance with troubleshooting. I'm keeping an eye on that chat window, so if somebody does need assistance, please pose a question there and I'll try to help you as best as I can. And with that, I'll turn that back over to Irfan.
So I don't have anything more, but I'll be transitioning to Michael Kircher, who will be next talking about the overview of the NWSC facility, and then we'll move forward with the rest of the site tour. Michael, you're up next.
Hello, everyone. Welcome. I appreciate everybody coming today. Normally, we would not be able to fit this many people into our conference rooms and stuff, so this is pretty exciting that you all get to see our facility. This is our first virtual tour of this style, so please bear with us, and I hope that everyone gets the information that they need. I'm going to start presenting. I got 2 slide decks, and then we're going to run through 8 videos to try to show you the lay of the land of the NWSC. All right, Summer, can everybody see my screen?
Yes, sir.
Okay, so this first presentation, we're going to be discussing the NWSC facility as kind of an overview. Again, my name is Michael Kircher. I'm the NWSC-3 Facility Infrastructure Lead. The NWSC is a Tier 2 data center. What a Tier 2 data center is, it has redundant capacity components, single non-redundant distribution paths serving the site's computer equipment. Some benefits of the Tier 2 facility include roughly a 99.7% uptime, partial redundancy in power and cooling, and roughly 22 hours of downtime per year. I think our numbers are probably better than that on our UPS equipment, but we fall into the Tier 2 category. So to first talk about our Module B computer room, this originally housed all of the IT equipment for NCAR and UCAR, including HPC compute systems. There's UPS and utility power sources available. There's 3 megawatts from each of these sources. And through the NWSC-3 process, Module B is kind of getting a change of mission. It's going to be more specifically used for UPS backed up critical equipment. This will include things like our storage systems, HPC test systems, and critical network infrastructure. Next, we're going to talk about our NWSC Module A computer room. The Module A layout is for HPC specific high density loads. The NWSC-3 project is slated to add 1 new 3 megawatt transformer to be installed on the south end of the room. And then we actually have design prepped where we can actually take this room up to 12 megawatts through future build outs. Our direct utility is the primary power in this module. We will have the possibility to be able to place a smaller UPS system for critical nodes and or networking gear if there are major cable length limitations. But for right now, we are planning on that being primary utility power. So kind of the NWSC approach to HPC. Our critical equipment, storage, and network is on our UPS with generator backup. This is N+1 fully redundant all the way to the server level. As we go through the presentation, we'll talk about this some more. And then our compute nodes are fed by utility. We try to strive for what we call an A-B configuration. What we do is we split the utility feed. We try to feed half of the HPC system with 1 breaker and the other half with another breaker, hoping that we could potentially take 50% of the HPC down during electrical maintenance and maybe keep some production going. We understand that sometimes this isn't fully allowable because of network restrictions and components within the racks, but it's definitely something we would like to talk to all the vendors about trying to strive for. To talk about our utility provider, we use Black Hills Energy. They are one of the top 10 utilities for system reliability in each of the last 5 years. This has been rated by the Edison Electric Institute, as well as the Institute of Electrical and Electronics Engineers. So our NWSC UPS configuration, we have 2 UPS sources with independent medium voltage transformers. Both of these UPS sources are provided at the rack level. What this requires is dual-tailed N+1 fully redundant power supplies at the server level, as well as N+1 fully redundant at the PDU level for all of our critical equipment. What this allows us to do with the facility is we can actually shut a UPS system down and we can remain in production on all of our critical systems. We can bring that back up, and then we can take the other side down to perform the needed maintenance we have to do. It has been a great design feature of our facility, and as long as the equipment is provided this way, it allows us to do a lot of great maintenance while keeping everything in full production. So our UPS powered equipment at the NWSC is networking equipment, NCAR owned, definitely. And then we would also like to talk to the vendors about potentially powering some of the cluster switches and other things off of our UPS sources, if possible. We also power our HPC head-end nodes and all of the other HPC critical equipment off of UPS power. Our out-of-band switches, our test systems, and then we prefer that all of the CDUs or mechanical equipment associated with the HPZ provided by the vendor is also powered off of UPS. This guarantees that we can keep the system cooling in case of a power outage, to get all the heat out of the system to try to prevent as much damage as possible in the case of a power bump. All of this has 4 megawatts of generator backup provided. The transition is roughly 30 seconds between UPS and generator. So to talk about our redundant power feeds for critical resources. So equipment identified as critical and needing to remain powered through UPS shall have the following: an N+1 power supply at the component level, dual-tailed, as well as N+1 power distribution units at the rack level, which are dual-tailed. The power test that we do for these critical equipment is each UPS source will be completely shut down, one at a time, and all equipment shall continue operating in full production capacity. We will then bring that UPS source back online, and then take the other side down to make sure that we can still stay in production during that time. You're going to hear this probably a lot through this, but is a very critical part of our design and is something that we need to make sure that the vendors understand. So some of our HPC equipment electrical protections. Currently, we have a sag shunt of around 5% adjustable. So what that means is we're constantly monitoring the voltage from the utility coming in for feeding directly to the compute nodes. If that has a variation of below 5%, we automatically shunt the main breaker to protect the equipment and try to keep any major sags from rippling through the system. We also have surge suppression support throughout the facility. We have it on our inputted switchgear, and then all other switchgear downline also has surge protection associated. So we're not only protecting from the outside, but we also protect from the inside. We also have an ATO scheme for our UPS and generator systems. We actually just upgraded all of this, so our UPS and generator transition is much more reliable and robust and hardened. We also have some wraparound capabilities in case of major issues within the site or during some major maintenance, where we can actually wrap around power through the facility to get things powered that need to be up and running during maintenance windows. One thing that I would really like from the vendors through this process is what kind of voltage tolerances are allowable for the equipment that will be supplied. I think if we can work together, we can make this this system have better uptime numbers, and we can all feel comfortable with how it's being protected as we move forward. So a little bit about the NWSC-3 mechanical system overview. So we have an open loop on our condensing water. This has a floating set point because we primarily use heat exchangers. So depending on the outdoor wet bulb temperature and the current load in the system, we can actually float the set point on our condensing water temperature to make sure that we're producing the 65-degree chilled water on our closed loop. That is primarily done through heat exchangers, as I told you before, but we also have a 1,000-ton chiller as secondary and backup to those heat exchangers. Through this graphic, you can kind of see as well that we have heat pumps connected into the cooling system. We actually take the reject heat off of the computer, we send it through our energy recovery heat pumps, and then we recapture some of that heat, so that way we can heat the building through the winter. We do things like heat our concrete outside in our visitor center. Do we have a question? I'm sorry.
Nope, it was a join.
Okay. So our IT equipment and our free cooling system. We use heat exchangers. We have 3 1,200-ton plate and frame heat exchangers that we can use and rotate through. It is N+1, so that way we have a spare heat exchanger as we perform any kind of major maintenance. We can make sure that we still have plenty of cooling for the systems without having to worry about any kind of unexpected shutdowns. The chilled water is a closed loop. The condensing water is an open loop. And as I talked about before, we have the 1,000-ton York centrifugal chiller as the backup to all this. We also have a chilled tank on site. That's 135,000 gallons of 65-degree water. This is somewhat of a mechanical UPS. If we have a major problem with our condensing water loop where we're not able to reject the heat out of the building, we can actually transfer to that chilled tank, and it gives us approximately 30 minutes of cooling at 4 megawatts of load. So that way we can either try to troubleshoot and get our condensing water system back up and running, or it gives plenty of time for us to get a hold of the admins to try to slowly bring down the super in case we need to shut it down. So our chilled water set point for HPC. Currently our IT chilled water loop is running at 65 degrees Fahrenheit, which is about 18 degrees C. We're an ASHRAE Class A1 facility, but I know as some of these systems come out, we're using things a little warmer than 65 degrees, or that's preferable to get above that. We have plans for those scenarios where we can add mixing valves or some subloops with other heat exchangers to gain those higher temps if the system requires it. So to talk about some of our mechanical system redundancies, we are N+1 on all critical components. This includes the air handlers that feed our UPS rooms, our cooling towers, our heat exchangers, the generator backup for all the mechanical systems, and then as I discussed, the chilled tank reserve, and you can see that as the white tower next to the large white silo-looking thing next to our cooling towers. The HPC and parallel file system main 65-degree Fahrenheit chilled water pumps are always moving water. Those pumps are on UPS backup and generator backup. This ensures that if we do have a major power outage, that we are constantly moving water through the system to make sure that the HPC is at least getting some flow through it. And then as we transfer to generator, the condensing water system kicks back in, and then we can continue to cool things. So this was the first slide deck I had. Are there any questions from anyone?
So there was a question posed in chat asking, and I just wanted to bring the attention to everyone about it. They were asking if the charts and other material will be available after the meeting. And the answer to that is yes, we're going to post them on that same NWSC website, NWSC-3 website. If you do have a question, go ahead and pose that in chat. And again, the chat window is over in the right-hand side.
Okay, well, I'm going to move on to our next presentation. Okay, now we're going to talk about an overview of the NWSC-3 HPC and PFS systems, production and test as it relates to the NWSC. So transportation and delivery to the NWSC. Our loading dock hours are normally 7:30 a.m. to 4:30 p.m. I also wanted to just bring up some of our current COVID-19 logistical changes. Currently, our equipment is being quarantined for 14 days before handling or install. PPE is needed in all areas, and it is provided by the vendor for their employees. As we move through these interesting times and changes in guidelines, will definitely be shared with all the vendors. But as of today, this is kind of how we are operating. So our NWSC loading dock, we have dock levelers on 4 dock doors. We have a large turning radius to get to the dock doors so we can accept any truck length. And our dock is at the same level as our computer room, which you'll see through our videos. You can see a picture of some of our crew. This is when we loaded up part of our NWSC-1 Yellowstone system as it went to Stanford for use again. So NWSC equipment staging. So right off of our loading dock, we have what we term as the service corridor. It is a very large area. It's approximately 3,500 square feet. In this area, this is where we can decrate any material, we can get it unpacked, and we can get it acclimated. This area is directly adjacent to both Module A and Module B, and we have double 10-foot high doors in order to roll all the equipment in. This makes deployments very easy. The next thing I would like to talk about is the NWSC-3 Move-in. So we use floor protection as we move the equipment in to try to save any kind of delamination on our floor over time. So the first level we put on is 3/4 inch plywood. And then on top of that, we stagger 1/4 inch masonite to help harden it and roll the equipment across. As we stagger it, it also locks it all together, so it's a lot easier to move. And also please be aware that NWSC staff assistance and oversight will be provided during these rollouts. You can see in the picture, this is an example of the masonite and the plywood on the floor, moving a large rack into our existing storage space. Floor capabilities. So our floor capabilities, we have a point load of 2,500 pounds uniform, or 625 pounds per square foot. Our rolling loads are a little less, with a point load capacity of about 2,000 pounds, and this is after 10,000 transits over the floor. The NWSC uses Concore floor panels filled with the cement material for added strength. So expectations for our install teams. So there's a required site video. This is for new visitors only. If you've been to our site and you've seen the video, we have that documented and you don't have to watch it a second time, but any new visitors will need to watch that before they're allowed into our computer room spaces. We have NWSC physical security on site. There's a daily check-in where a badge will be issued to the vendors, and then a daily checkout where the badge is then returned to security. This is for all visitors, even UCAR staff from Boulder do this. It's just a way to make sure that we can keep tabs on where all of our badges are, and we know who's been in and out of the facility and if they've left. The facility is about 150,000 square feet total, so it just helps us keep track of all the people that are coming in and out. We also have flexible working hours during these kind of installs. We do appreciate talking to the NWSC management team before you decide to do that to get prior authorization. There is some eating and refrigerator space available for on-site install teams for breaks. And then there's multiple takeout, delivery, and other eating options within Cheyenne. So our parallel file system and high performance computing test systems. Module B is the preferred location for both of these systems. This is a picture of Module B. Kind of in the top center, this is where our current storage is, and then you can see where the future storage is planned. The test systems for PFS and HPC, just to be aware, they do transition to a production system after final acceptance. That production system is the AMPS, Antarctic Mesoscale Prediction System. This is where models get ran to help make sure that planes can fly in and out of Antarctica to bring supplies and equipment to the great staff that are working down there. So some cooling considerations for the test systems. For the test PFS, air-cooled is preferable. And then for the test HPC, air-cooled or water-cooled racks can be accommodated. Normally, this infrastructure is installed with my team in-house without the use of vendors because it's usually happening a lot faster than the construction rollouts that RFPs that I get done. So good communication is definitely needed as we get into the test system phase. I'm definitely gonna have to work with the vendors to make sure we have good lead times and we understand exactly what you need so we can have it in place when those systems get delivered. So site integration for the UPS test systems. All test systems will be powered via UPS. This is because of the AMPS project, and it also becomes when I have to do electrical maintenance on the utility fed equipment, these test systems become a place where we can put users on to get some production while we're down working on some things. We have 208, 120 volt, and 480, 277 volt available for these test systems. The parallel file set test system, again, needs to be fully redundant N+1 power supplies and PDUs. We will be doing the infrastructure test. While we de-energize one UPS source, it must stay functional, and then we will de-energize the second UPS source after we restore the first to make sure that it can stay functional as well. The HPC test system, the head end and critical equipment falls into the same as the PFS. It has to be redundant. We will be doing the same infrastructure tests on that. The compute nodes, we understand that that's sometimes not as possible to get redundant power to all of the compute nodes, so that is not required to be fully redundant to the PDU level on the compute node side, but just so you know, it will be being placed on UPS. So the parallel file system production going in Module B. The system will be located in the south part of Module B. And then I put some expected cable distances on this slide. I thought that might help the vendors understand the relation to all of this stuff. So from our current PFS system, which is closer to the north end of the room, to the new proposed NWSC-3 PFS system is approximately 160 feet or 50 meters. From the NWSC-3 parallel file system to our net hub, which is to the right of the Module B tag on this drawing. That's approximately 130 feet or 40 meters. And then from the NWSC-3 parallel file system to the NWSC-3 HPC system is approximately 130 feet or 40 meters again. So to discuss our HPC production system, this is going to go into Module A. Currently, we're getting ready to kick out and hopefully start the capacity construction project, where we're going to be adding our 3 megawatt transformer, getting our large mechanical headers through the lower space. There will be some design differences between the two modules. Module A is not going to have a ceiling in it. As you'll see through some of our videos, we have a large fan wall in lower Module B. Module A will only be getting half of the fan wall. And then we're also holding off on doing any cable tray design until we get closer to understanding the vendor needs, so we can make sure that we can optimize the cable tray installation the best we can. Some of the expected cable distances from this module. So from the west wall of Module B to the east wall of Module A, this is approximately 160 feet or 50 meters. From the NWSC-3 HPC system to the net hub, which is these blue racks that you can see here, that's approximately 140 feet or 45 meters. And then as we get further through this RFP process, and as you talk to Jared and some of the admins for SSG, you'll probably hear us talk about the Casper cluster. The distance between the Casper cluster and the HPC system is approximately 170 feet or 55 meters. So electrical for the NWSC-3 production system. The NWSC-3 parallel file system will be powered from our UPS. Again, it's fully redundant, N+1 power supplies and PDUs. We will be performing the UPS functional test, as I've talked about earlier. The NWSC-3 HPC critical equipment will also be UPS powered. Again, this is also fully redundant, N+1 power supplies and PDUs, and we will be performing that test as well. And then our NWSC-3 HPC compute nodes, these will be powered by utility power only. In my previous presentation, I touched on the protections that we provide for that. And then also we've talked about the AB configuration. If possible, as you're designing it, we would like to see if that could possibly happen to help us with maintenance and also keep our uptime numbers better. So the mechanical portion of the NWSC-3 project, we anticipate the parallel file system to be air-cooled. We supply 72-degree Fahrenheit supply air with 40% humidity. As we go through some of the videos, you're going to see our hot aisle containment. This is built by the NWSC facility staff, and it will be implemented on the parallel file system to maximize efficiency. The NWSC-3 HPC compute nodes, we're expecting water cooled at the component level or some kind of rear door heat exchanger, or maybe a combination of both. We have 65-degree Fahrenheit water available, but again, as I talked about, this can be adjustable with the use of mixing valves or heat exchangers. The NWSC-3 HPC critical equipment, again, we're supplying 72-degree air with 40% humidity. If possible, we will be building hot aisle containment around this as well for efficiency. And then depending on the design, water cooling is also available for this equipment as well, depending on what the vendor's engineers come up with. So to discuss some of our electrical and mechanical connection methods located under the computer floor for the production systems. Electrical, so far we've seen mostly pin and sleeve receptacles. As you can see in our picture, here's some examples of our pin and sleeve connections. We've also seen other sites that use things like disconnects or other type of methods As long as we're within the National Electrical Code and we are compliant, we can provide pretty much any kind of disconnecting means that are spec'd out by the vendors. Mechanically, if it's an air-cooled system, we use the hot aisle containment. If it's water-cooled, you can see these flex hose connections. We've seen these dairy-style hoses used or the hydraulic-style hoses used. We can accommodate either one. We do try to provide isolation valves at each of these points, as well as drain ports, so that way we can work on a specific component of the system without having to drain the entire thing down when needed. And we also try to provide balancing flow sets to make sure that all of these cooling racks are getting exactly what they need from our system. So some of the monitoring capabilities that the NWSC facility has, we have mechanical monitoring through our building automation system. We use Johnson Controls, Metasys. Some of the protocols that we use are BACnet and BACnet IP, Modbus TCP, as well as LawnWorks. We also have an electrical power monitoring system, or an EPMS. We're using Wonderware systems. The protocols used, Modbus IP, Modbus TCP, DNP3, and then other protocols can be added to our translation server for this system. CDU monitoring and maintenance. If some of the vendors I know have CDUs planned as part of their solution, my team, the NWSC infrastructure staff, prefer to direct CDU integration into our BAS. This can either be done through BACnet or IP-based, but it allows for 24/7 monitoring of the CDU systems outside of what's provided by the vendor solution. This has worked extremely well with our current system. It has allowed us to catch a few things that I think may have taken a long time to troubleshoot, and we would definitely be interested in talking to all vendors about how to direct integrate these kind of components into our system. I also wanted to touch on CDU maintenance activities. The NWSC on-site staff is definitely willing to assist in any crews or FRUs associated with the equipment where applicable. Understand that as the facility team, I have 3 licensed electricians and 3 licensed mechanics that can pretty much tear down and put anything together mechanically or electrically, and we are more than happy to be that first line on-site troubleshooting staff for these kind of components. So to talk about our HPC power monitoring capabilities, this is just something I wanted to throw out there for everyone to think about. NCAR has a high interest in testing power data integration with the NWSC-3 system and the NWSC facility. Some of the things I would like to throw out to think about is there any kind of Modbus or power monitoring protocols available within the clusters that you will be providing? Is there direct integration to our site EPMS system, and is it possible? And how can this be accomplished? Can we use a 2-wire bus system or IP connections? But without a doubt, this is something that we would be very interested in partnering with a vendor to try to further the integration between the HPC systems and the facility. So that's the second presentation I had. Are there any questions?
And again, just use that chat window on the right-hand side if you do have questions. Go ahead and type that in. For those who For those who came in a little bit later, I'm going to post a link to a registration form. I think that we're going to have some time to fill that out here shortly, but I did want to make sure to post it here. Looks like we do have a question from Joe Prisco. The first question is, with n+1, what is the typical n?
Okay.
Like n equals 1 or n+2, etc.
So I guess what we mean is at the server level, we want completely redundant power supplies. So n would be only one power supply. n+1 would be a second power supply, and both of those are redundant, completely redundant to each other. So one can completely lose power and the box will stay running. Now that's at the server level, and we're also meaning that at the rack level as well. Does that answer the question?
I think we'll wait to hear. Yep, Joe says yes.
Okay.
He does have a second question as well. It says, can you explain dual-tailed? I think I understand, but just want to make sure.
So dual-tailed, like when you have a server box that has two power supplies and there's two cords that connect to that box, that's a dual-tailed server. So within a rack, it would mean that you would have two PDUs in that rack, and then that rack becomes dual-tailed.
Thank you. We do have another question here too. Thomas Dirks says, will 415 or 240 power be available?
Through the use of special transformers, we can get there. 240, we use 208, which is pretty much the same as 240. 208 is just usually with a three-phase system. 240 is usually a single phase or a single phase with a wild leg. So 208 is more of the standard. 415, I believe, is more of a European voltage, but we can probably accommodate if that is needed.
Thank you.
Okay, well, I guess if there's no other questions, I think we can probably take about a 15-minute break, and then we can start the virtual tour.
So we will take a break until about, let's see, how about 9:20? Let's take a break until 9:20. Also, we're in Mountain Time, obviously, but go ahead and just leave your video conference up. Go ahead and stay muted. If you're not already muted, then go ahead and mute, and we'll be back here shortly. I guess everyone has a quick break for coffee and such. And what we're going to do after we come back is the virtual tour. We're going to walk you through the facility, show you the floor plan, talk to you about those components, and you'll be able to ask us questions about that video as we go through the facility. So you'll be able to see the physical layout and what we have in place when we come back from break. So we'll see you at about 9:20. Joe, thank you for posing your question. I'm going to have them address that when we all come back. as we get ready to go into our next part of the presentation. We still have some time during break here, so don't panic. I'm not getting started or anything like that. Just asking Michael for a mic check.
Check, check. Can you hear me okay?
Yes, sir. Sounds
Awesome.
good.
Thank you.
Okay, so it's 9:20. We're going to go ahead and get started here. I do need to remind you that in the right-hand side, we do have the chat window. So if you have questions along the way, feel free to post them there, and I will make sure that Michael hears the question as we go along. We're going to walk you through the facility, and so I'm going to show you a quick map here. We'll talk about what we're about to see, and we'll walk you through the facility live. Again, if you have questions, pose them in the chat. Let me get a few things ready here. All right, and then I'm going to start my screen share. Here we go. So our facility is Architecturally, I think it's one of the nicest data facilities I've seen. It's out on the plains, so as you can imagine, we have quite the view out here. What we're about to see is Michael's going to take us through the beginning of the building. We're going to start in section 1 here, which is the main lobby. And actually, I'm just going to play this video. He's waiting for us in our data center. So Michael, you can go ahead and stay there. But I'm going to play this video, and it's going to take us from this main lobby entrance, which you saw in this picture here. And we're going to go through over to module B, which is our data center room. Also, our videos don't have any sound, so that will allow Michael to kind of talk to us about what we're seeing in that room as we go through. But for this first main lobby one, I'll kind of give you the overview of that. So let me get that started for us here. So this is coming into the front of the facility. And as we go through, we have the large windows here. We have a small visitor center where we talk about parallel processing. We talk about the work that UCAR and NCAR does. We are sponsored by the National Science Foundation, and we also have partnerships with entities in Wyoming because we have those partnerships that helped us bring the facility into that area. So as you come through here, this part of the building, we do have tours often. That's generally what I do when we are open to the public. We can provide 2 busloads of students there, and we educate them about all things supercomputing and all things science, atmospheric science related. As we look into the windows here, you can see there are a wall of filters down below. That is our airflow corridor. We do have a 10-foot raised floor, and that's what you're seeing in that video. The 10-foot raised floor allows us to circulate that air efficiently and keep the room cooled using that kind of airflow. So as we come through here, this is the corridor. We have the knock across the hallway from the supercomputing data center. And we're about to enter into the supercomputing data center here. You can see those 10-foot tall doors at the end of the hallway there. All right, let me get the next video queued up for us here. Again, if you had questions for that so far, go ahead and post them in the chat. So here we're about to see, as we enter into the data center, this is module B. Again, module B is where we have a lot of that infrastructure already located, and we are looking to add to module A as well.
So now we are getting close to our networking hub. So you can see these racks is where the main networking comes in to our computer room spaces. You can see some of the tool storage that we have, some workspaces for techs, and then these first sets of racks is where our main routers and the main networking comes into the room. We also utilize fiber cassettes and patch cables across the room. This helps us deploy network cabling a lot faster. So these are some of the cassettes that we've used. There are patch points throughout our cable tray where we can easily get connections into pretty much any rack we need. Now you're starting to see some of our copper racks. This is where all of the copper connections for most of the room come in, where we can patch to get across various parts. And then as we're turning, we're starting to look at storage. And then right here to the left is Casper. Okay. As we come out of this, we're seeing Casper on the left. The center there is kind of our current HPC head-end nodes. we have a small pod we're starting for object storage, and then you can see our current file system here. It is closer to the north end of the room, and then you can see some of the access points. This one straight ahead accesses us into the service corridor, and then these other doors allow us to get in between the modules. Another look at some of our networking equipment. And then again, a closer look at our current file system. Now this file system is about in the center of the room. So we actually have pretty much a straight shot of cable tray from this location from north to south across the room. So we can get cable easily from the current file system into the new file system, or if we have to, all the way into the future NWSC-3. We have just deployed some of these racks, so we haven't got the hot aisle containment quite completed, but that pod behind it, you can see kind of what our hot aisle containment looks like, and then you can see a clear view from north to south of the data center. Here you can see one of the 10-foot doors. You can see this is where we transport equipment into the room, and then we can lay that plywood and masonite along the darker tiles that you've seen on the floor. All the white racks are co-location outside of this next white pod that we're coming up on the right. That is actually the head end for our storage. Okay, now we're kind of looking at the south end of Module B. So this is where the NWSC-3 parallel file system is planned to set. You can see that we have cable tray in place about 10 feet off of the floor, easily to get to this new equipment. And now we're walking back towards those windows that Summer showed you in the first video that showed the Module B computer room. This is where the return air is coming from all of the hot aisle back down, and then we recirculate it through our fan wall down below. You can see the darker gray tiles on our floor. Those are walkways. The lighter tiles are where we place equipment. And now we're heading back towards the knock area.
So I just wanted to point out that we had covered, coming in from the main lobby through that visitor center, we came into Module B, which is where our current data infrastructure is located, and we took a view through here as well. So what we're going to look at next is going to be down here in the loading dock area, as well as Module A, and then we'll take a view downstairs underneath Module B and Module A. So this is our loading dock.
And then you can see this is our service corridor that we've termed. This is where we can place equipment, get it acclimated, get it uncrated, get it all ready for deployment. And then these 10-foot doors that you see on the left is how you enter into Module A. Now we're in Module A. You can see the open ceiling. This will be left that way during construction. And you can see the wide open space we have. Right now we are currently on the north end of the room. NWSC-3 high performance computing will be on the south end, where you can see across there where those windows are. Currently we're using these places to stage equipment that is going into Module B. All this will be cleaned out before deployment. Some of the lighting will get redone. The plan is if there's any hot aisle containment in this base, we will pretty much chimney it up too close to the steel, and then we will let the 2 sections of fan wall just naturally take that hotter air and recirculate it back as needed. Where that bump out is, that is where all of our networking gear is. So you can see that that networking gear is pretty much truly in the center of both data spaces to try to optimize the cable lengths and make sure that we can get as close to possible to all of these high-speed networks and equipment. We have different perf tiles and solid tiles. These can be configured in any way needed for the new system. As we come across here to the right, you can see we have a stairwell that allows us to get down below the floor easily. And then we also have multiple doors to get quickly between the modules. That one leads right to the networking gear. And you can see this is all the space for NWSC-3 high performance computing. Roughly 12,000 square feet of space. The door that you see here, this is where we started the Module B video. So this is the door that can quickly and easily get you between Module A and B, right between the new parallel file system and the new HPC system that will be getting installed. Now we're going to take a picture, or take a look at our loading dock a little bit more. So now this is coming from Module A, going back through this door into our loading dock. You can see right now it's full of tape library equipment, but we do have 4 roll-up doors that are easily accessible for 4 trucks. It is at the same level as our computer room, which makes deployments very easy. Right in front of the door, you can see the dock levelers. And then as we're walking through here, you can see we have a 10,000 pound rated elevator to get us through the plant as we deploy the large infrastructure needed for the build out. That lighter gray in the floor, that's our 10,000 pound scale. We can weigh any of the racks needed as we roll them onto the floor to make sure that we're not exceeding any weight ratings that we have. And then as you look out the window, you can see the large space where we can have any size truck can easily fit into our loading dock area. And then again, that white is our large chilled tank associated with our cooling system. Here's a view of coming out of our elevators into the loading dock. Again, the 4 doors, plenty of space to get things out of the truck, and then roll through that other roll-up door into the service corridor. We do kind of treat this area as a airlock, so that way, if the outside doors are open, that door into the space is closed, so we don't let any contaminants get into the data center. The next videos we're going to do are down below, so as I transport myself downstairs, Summer's going to run through some of her educational presentations.
Absolutely. So one of the things I do want to remind everybody is if you do have questions, go ahead and put them in chat, and I'll just make sure that we get Michael's attention to kind of stop and talk about some of those things. What I want to show you guys today is sorry, I'm just getting a couple of things ready here. Kind of a virtual tour through our facility, that loading dock and the staging corridor that Michael had pointed out. So this is where I'm going to begin this part of our virtual tour. I just want to point a couple of other things out. We're coming out of Module A and Module B, and let me just pull up that picture here again to show you the lay of the land and where we were. Module B is the one that faces those glass windows that look out on the lobby, and then Module B is the one that faces the lobby. Module A is that open, empty space that Michael had showed us. So one of the questions I get when I give tours is, why did we build out Module B first? And it was because we would like to show everyone and use that as an educational resource. And so we want that to face the lobby as well. So when you leave Module A or Module B, you come into this main access corridor. And again, it's attached to the supercomputer floor. It's the same level, and it is attached to our loading dock. So when a supercomputer comes in, it comes in at this end, which is where that loading dock is located. And then those crates all fill up this area to kind of acclimate to our environment. If we go outside, we've got that water tower and cooling media that Michael had pointed out. I do want to talk briefly about that. We have this very high efficiency water cooling tower, and that's where we're storing that 135,000 gallons of 65-degree chilled water. Again, it will provide us about 30 minutes of cooling if we are experience any kind of issue, and that's at 4 megawatts of load. So this is the water holding tank, and again, that's 135,000 gallons of chilled water. These are the cooling media units, and I'll kind of describe what they do here. They run in 3 phases. The first is 30 degrees wet bulb temperature, and really this is where we get a lot of our efficiency in our facility. The cooling, the water comes through here and is cooled naturally by our Wyoming air. We have a lot of wind here in Cheyenne, so it's an ideal climate to host our data center. But the water runs over the cooling media and then returns to the building in this first phase, which is 30 degrees wet bulb temperature. At 55 degrees wet bulb temperature, the fan kicks on to help that cool a little bit more. The water drips over the media and then returns to the building. So that's phase 1 and phase 2. We operate at phase 2 most of the time. Michael had mentioned that we have a 1,000-ton chiller. We only use that maybe 7% of the year, and that's this phase 3 that our cooling system operates in. So we don't have to engage the chiller that often. So talking a little bit more about where Michael is downstairs now, this is also where that water heat exchanger is. And I just want to talk about those 2 loops here. This is what we call free cooling. So that water cooling tower is cooling the water, and this is our open loop system. It comes, it is exposed to the air. It comes through our lower level to that heat exchanger, and then this loop runs next to the closed loop, which is what is helping cool the data center. And because of that heat exchange process, this cooler water on the condensing side helps naturally cool that water that is then supplying the data center side. This is what it looks like downstairs. Again, we have the condensing side here. That's at about 65 degrees. And then we have the water coming from the data center. We do have, normally when I'm giving a tour in person, I point out these thermometers, and the water coming from the data center is usually about 72 degrees. And through this free cooling heat exchange unit, it's chilled back down to about 65 degrees. And again, we call that free cooling. So I'm just going to check in with Michael real quick and see if he's ready. I'm going to pull up our map again so that we can talk about where he is in the building now. All right, so Michael is currently below Module B, which again is the one that faces that visitor center. He's downstairs. This is where our fan wall is, underneath our current populated data center room called Module B. So I'm going to start that video.
Thank you, Summer. So you can see this is our lower module space. It's a 10-foot raised floor. To the right, you can see our fan wall. It's 96 fans, all run in parallel. We can move up to 400,000 CFM. And then you can see all these vaults that are in the floor. And then we have one with plexiglass over it. This allows us to pull the large power conductors between all of these vaults to anywhere we needed, from our UPS 1, UPS 2, or our utility sources. This allows us to keep that large piping from having to clog up the upper part of the floor. And then as we walk through, you can see to the left there's a top hat that ties into some equipment. And we have some transformers. This is some of the current equipment feeding our current parallel file system, all on UPS. Then as we make our way farther down, you can see this is roughly where our air-cooled equipment stops, and then we start getting close to Cheyenne, our current system, which is fully water-cooled. We strive here to try to keep our electrical infrastructure aligned with our columns. So to the left here is all the electrical infrastructure for Cheyenne. It's all 480 volt 277. And then you can see hugging the columns, we used that top hat in the center to get power to the main distribution panels and then distribute it through the branch circuit panels. And then up above, you can see that we try to keep the center of the aisles ready for the large hydronic piping that needs to come through for the water-cooled systems. You can see some of the hose connections on the top, some of the power connections lower on the left. And then as we pan up a little bit, you can get a little bit more detailed view of how exactly we're coming off of our header, tapping off with our flow sets, our balancing valves, isolation valves, and then connecting it into the hoses that eventually go up through the floor. You can see that we have the surge suppressors next to all the panels. And then this is one of the panels that we're feeding all of the mechanical equipment for the current system through. So we have both sources of UPS available through a transfer switch. And then as we walk closer to the large header that runs underneath the module to bring our 65-degree chilled water, you can see how we offset up. A lot of what we use here is 45-degree bends to try to increase pump efficiency. And then you can see the length of that header runs north and south underneath the room, so that way we can connect to anything that we need to through any of the spaces of the floor. As we're walking back towards the south, this is some of the remaining infrastructure from Yellowstone that we may be able to reuse for this deployment. And then you can see some of our network boxes for the plant. And then the next is we're going to look underneath Module A. So this is the view of Module A. You can see that it is ready for build out. You can see this large gray pad right in front of us. That is actually a 6-foot vault. That is where our 5,000 amp main breaker switchgear will set from the utility to feed the compute nodes. Then you can see that we have a similar setup with all the vaults for the electrical conduits to bring UPS or utility into the space. as we walk farther in here, currently we're using some of this for storage. All of this will be out of the room before deployment. But currently where this plywood and other stuff is staged, this is where 2 sections of our fan wall will go to help just circulate air. And then on the far wall that you can see on the other side, that's where our 24-inch header will go. This is kind of the walking corridor. All equipment will more than likely be in between the columns to the left above the vaults. Sometimes it does extend into the space. We just have cable tray that is tucked up tight, so that way we have good walkway access. You can see we also have double doors into the lower modules. This allows us to get our large switch gear through those doors, be able to be set without having to do any augmentation of the floor above. And that was the last video. One point of order I just needed to make, just so everybody is aware, that first video that Summer showed, walking through the visitor center and then the doorway into the NOC, that is where the secured areas of the building start. So from that point, any vendor that's on site, yep, right there where she's showing, any vendor on site, they have to always display their badge, and they have to use their badge at every card reader throughout the facility to get in and out of the computer room and into the NOC. They also need to check in with the NOC before entering into the computer room. But overall, I believe that pretty much concludes the virtual tour of the NWSC. Are there any more questions?
And again, just feel free to put your questions in chat. Michael will see them, and I'll be able to get his attention if you know he's walking back through the facility. Irfan, is there anything you'd like to add during this time while we wait for any questions to be? Okay, looks like Irfan has submitted a chat as well. You can submit questions in writing and email to Allison Probst by Friday, May 1st at 5 p.m. Mountain Daylight Time.
Yeah, if you're unable to, get your question across during the virtual tour, you're more than welcome to submit it to Allison Probst from now till May 1st. Just remember that it's 5 p.m. Mountain Time, and then we will, provide you responses to your question along with anything else that comes up.
For anyone who hasn't filled it out yet, I'm going to, in the chat, just put that registration form again one more time to let us know that you were here and in attendance, just for our records. And that way we'll have your contact information if we need to reach back out again as well. So I'm going to leave this video call going for just a little bit so that folks can fill that out if they need to, if they haven't clicked on it yet. And we'll leave this open for questions for a few minutes as well. As we mentioned at the beginning of this video, and if you hadn't seen that, we are going to post this video as well as the questions on the NWSC-3 website. Also, I just want to take a moment. I would like to introduce Gary New. He is the facility manager for NWSC. So I'd like to turn it over to him for just a moment.
Good morning, everyone. First of all, I want to point out and thank Summer, Michael, Jim, Van Dyke, the rest of the staff that put this together. As we all understand, these are unprecedented times, and this was put together very quickly to try to accomplish this. And I guess if the NFL can hold a virtual draft, we can do a virtual tour for this facility. So I just wanted to say thank you to my staff for the excellent job that they did putting this together. Thank you.
Thank you, Gary. And again, if you have questions, go ahead and put them in the chat window. We can see if we can address those live while we have Michael on site, and I'll leave that open for about 4 more minutes here. So at about 9:55 or so, if there's anything you're thinking about, just let us know and we'll see if we can address that. So I do see the question here posed by Jeanette for the URL to the NWSC-3 site. Let me grab that for you. I'm going to put that in chat. I'll be back in just a second here. And you know, as I go grab that, I do want to also remind everyone that in your Google Meet video window, there is a meeting title in the lower left-hand side. There we go. Irfan has posted that. Thank you. In that lower left-hand side, if you click the caret next to the NWSC Virtual Site Visit title, it does pop open and it will show you the agenda. And if you would like to download that PDF, you can have that as well. That is also listed on the NWSC-3 site, but it does show under that agenda that kind of information as well if you do need to reference that later. And again, if you have other questions, just go ahead and post them in the chat. Okay, Irfan, is there anything you'd like to add?
Yeah, I was just putting some information on the chat to give clarity of, you know, there is a tab on the main page which contain updates, and whenever there is any news or any update, or if we have responded to your questions, we do update this tab so you can go and look at it for the latest news. Also, in the question and answer tab, you will see basically all of the communication documents with the date they were released as well as the version. So before we end, if you have any question, please feel free to ask now, or you can submit it to Allison Probst by May 1st, 5 p.m. And I wanted to thank all of you for taking the time to attend this virtual site tour. I hope we were able to give you a good view of our electrical, mechanical, and other infrastructure at the NWSC. And we are hoping that you know, we will be able to answer any questions that come up from now till May 1st. So thanks again. Stay safe and stay healthy, everyone. Take care, and we'll talk to you guys later. I don't have anything summer. So if you want to keep the website visible for a few minutes, that's fine. But I'm going to sign off, and I'll talk to you guys later then. Thanks.
Thank you, Irfan.